Hello dear students, welcome back to our YouTube channel School for All. So today we are working example 2 2020 question 6F, still under secret problems RLC secret. Okay, now 2020, let us see what 2020 was proposing us. Okay, so the figure shows a 200 microhenry inductor, a 10 ohms resistor, and a variable capacitor connected in series. This is a variable capacitor connected in series with a 0.1 volt RMS. RMS means root mean square value, 1.0 megahertz supply. The inductor has an inductance of 200 microhenry. At resonance, so they say at resonance, determine at resonance Roman 1. A resonance Roman 1, determine the capacitance of the variable capacitor. A resonance Roman 1, we are asked to determine the capacitance C of the variable capacitor. Okay, now, student, so we all know that what? The condition for us to be a resonance is that LC should be equal to SL. So the capacitive reactance should be equal to the inductive reactance. From then I can find the value of C. So this implies from this condition I will have what? Omega L is equal to 1 over omega C. Don't forget. SC is for 1 over omega C, where C is the capacitance, and SL is omega L. So by multiplying all through, you have the same thing as we are doing things. Omega squared equals to 1 over LC. So from here, I have omega squared equals to 1 over LC. I'm looking for C. This implies I will have LC omega squared equals to 1. So we have C equals to 1 over C omega squared. But I know that omega is 2 pi F. Is it right? So my C is equals to 1 over, this one is L here, 1 over L bracket 2 pi F squared. So by replacing the value, I will have 1. L, what's the value of L? L is 200 times 10 to the negative 6. In Henry, okay, then times bracket 2 pi times the frequency. You get the frequency megahertz. Megahertz means times 10 to the how many? Times 10 to the 6. So we'll have 1 times 10 to the 6. So that's it. So after numerical application, you will have 1.27 times 10 to the negative 10 farad. So that is it. You can still put it in, because like this, if I bring this decimal here as 1, 2 times, I will subtract the power by negative 2. So it can still be equals to 127 picofarad. That's it. Okay. So the same thing. It can still be equals to 127 picofarad. Another pico is times 10 to the picofarad is times 10 to the negative 12 farad. So by moving a decimal to the left, no, let's say to the right, I will subtract the power by 2. So that is it for Roman 1. Now let us move to Roman 2. Our portion, we are still at resonance, so we are asking to find the current flow in the circuit. We all know that at resonance, the current flow in the circuit is maximum, so we are calculating the maximum current. Okay, so from VRMS equals to Z times I RMS. I make RMS the subject. I want VRMS divided by Z. Remember, a resonance Z is simply equals to R. A resonance Z is purely resistive. So you only make up of R because these two are equal, and you cancel out from the formula Z equals to square root of R squared plus XL minus XC all squared. If these two are equal, I will have 0 there. The impedance of the circuit is simply equals to R. So by replacing the value here, another one, VRMS 1 0 volt divided by Z, which is who? R, and R is how many? 10 ohms. So after dividing these two, you come out with 0.01 amperes, which is the same as 10 milliamperes. As easy as that. So without wasting time, let us go to Roman 3. Okay. Figure of the question is saying calculate the voltage across the inductor. You are still at resonance. We want the voltage across L. Okay. So we know that VL is equal to what we call the inductive reactance, XL, times the current that we are just calculating IRNS. So that's it. And we know that what the inductive reactance is omega L times INS. So omega is 2 pi FL. So by placing the value, I will have 2 pi. The frequency is times 10 to the, look at 1.0 megahertz. Mega means times 10 to the 6. Times 10 to the 6. Then times the inductor, which is how many? Inductor is 200 times 10 to the negative 6. Times the current that we are just calculating, which is times 0.01. So we'll have something like 400 pi, which is slightly equals to 1257 ohms, 1257 ohms. So that is the value of XL. So we will now multiply it by the value of the current, which is 0.01. So that we should have 12.6 volts. So you take this now, the value of the inductive reactance multiplied by 0.01 to have the voltage across L. Okay. Now let us go to the last part of our question. Roman 4, still at resonance, we are asking us to calculate the voltage across the capacitor. The voltage across the capacitor here. So since we know that at resonance LC equals to SN, therefore the voltage across the capacitor is simply equal to the voltage across L. As simple as that. And we are just calculating the voltage across L. So the voltage across the capacitor is still 12.6 volts. So that's all about the question. So you see that RLC circuit is not difficult. If you know your formulas, you know how to apply it, that will be all. So you people should master all the formulas, take notes about the recorder with it, and apply it. So thank you for watching the video. Don't forget to subscribe to the YouTube channel so that you should not miss the other amazing video that is coming, because I think it's data analysis, mechanics, all those videos, they are coming. So thank you for watching the video.